And for our very last video of MA 215, we're going to look at paired data. So paired data happens when the two groups are not independent of one another. So typically this is a before and after situation, but the difference between this and the before and after of, say, when we were dealing with proportions is that this is the same person. Or say we're looking at a farm field, it's the same field before and after. It's the same person's pre-test, post-test scores. So it's not independent because it's essentially the same thing. So this one is actually the easiest one, but you have to be very careful that we're dealing with paired data, otherwise it doesn't work. So in this case, obviously this is a pre-test and post-test for a test over mitosis, which is the parent cell dividing into daughter cells. So these are the students' names, and this was their pre-test score, and then after the unit they were given a post-test score, and hopefully they all went up, but we don't know. Now when we're dealing with a question like this, of course they are not independent. We call this a paired t-test, which looks at the differences between each pair. So there's two different ways to do this. If it's an observational study, typically they call it a matched pairs t-test. If it's an experiment, meaning some treatment was applied, it's called a blocked pairs t-test or interval. Overall, it's called a mean of differences. Now, previously, we talked about the difference of means. Difference of means was where we found one mean and we found another mean and then we found the difference. Now we're going to find the mean of the differences, meaning that I need to find each of the differences. So I'm essentially subtracting these. Now notice when I found the differences, I took post minus pre, and I did that again for the ease of hopefully dealing with positive numbers, because if I take a post test, hopefully that score is higher. So I took what I thought to be the higher one, subtracting the pre-test. Notice that poor Anne actually did worse, and so did Sue. Those two, what do you do? But I'm subtracting them to find the differences. Now here's the good news. Now the only data that I care about is this row. I only care about the differences. So I don't care about the pre and the post. I just care about the differences. Now we already know how to deal with just one sample. If we're dealing with just one sample, it's just a t-test. So we already know how to do a t-test. We did it last week. So it's a t-test mechanically, but we just call it a mean of differences test, blocked pairs or matched pairs. Again, hypotheses, same as we did before. Assumptions and conditions, we know that the differences must be independent, but we know that the data actually must be paired. So the differences are independent because how I do on a pretest post-test doesn't affect how you do on a pretest post-test. Okay? Randomization and nearly normal. Find the mean and the standard deviation of the differences. Again, I would just use technology to make it subtract for you. Find the t-score and the p-value. Now, if we're using technology, like in StatCrunch, it will just do the differences for you, and it's going to be great. Again, for our conclusion, if p is greater than the alpha, we fail to reject the null. If p is less than alpha, then we reject the null. Again, don't say the alternative hypothesis, actually say what that is in context. So here's the same question that we just had, or the same data that we just looked at. We're testing an appropriate hypothesis using an alpha level of 0.025, so 2.5% as opposed to 5%. And we're trying to determine if a student's increased mastery after the unit. So of course, if they increase mastery, that means that the difference is going to be greater than 0. Now, notice for a moment how we're writing our hypotheses. On all of the other questions like this, we did p hat 1 minus p hat 2 equals 0. Or we did mean 1 minus mean 2 equals 0. This is the only one where I'm not going to have subtraction, because this is the mean of the differences is equal to 0. Or the mean of the differences is greater than 0. Greater, again, because hopefully we increased mastery. Checking conditions, paired. Obviously the scores are paired. It's the same person before and after. The independence assumption, the differences in scores by student are independent. Randomization, nearly normal. And then this is a blocked pairs t-test. It's blocked because essentially this is an experiment. We're applying the treatment of teaching them about mitosis. Again, we can certainly do these calculations by hand, so let me show you that very quickly. The mean of the differences, essentially what I did was I took that one row that had all of the differences in it and found the mean of that and the standard deviation of that. So that's where I came up with these values to find the t-score, and then my p-value of 0.15. So notice I have my pre and my post-test scores, and instead of creating a column that has the differences in them, I'm just going to let StatCrunch do all of that work for me. So I'm going to go to Stat and T-Stats and then go to Paired. And again, I think the post-test is going to be higher, so I'm going to put that first, and sample 2 is in the pre-test, and I can save the differences if I want. So if I want to save what the actual differences are, I certainly can do that. My null was that the difference was equal to 0. My alternative was that it was greater than 0. Make sure that you change that to the appropriate one, and then I can compute. So notice it was very nice, and it created those differences for me. In addition, it also found my test statistic, my t-score, and my p-value of 0.15. And then of course it says differences are stored in column differences. So it was nice to do that for me so I didn't have to. Either way, whether you do it by hand or using technology, the p-value is below our alpha level of 0.025, so we reject the null. There's evidence to support that on average, students scored better on the post-test than they did on the pre-test. Otherwise, I would feel really bad as that science teacher. Doing a confidence interval, of course, same idea. We already know we already know how to find the mean of differences. Again, we can let technology do that. The sample difference is 15.125. That's what's here. So I can either do summary statistics on the differences column or just let the calculator do everything. 2.365, again, this one for degrees of freedom, it's easy again. So there were 8 samples because we were only dealing with the differences. I don't care that there were 2 scores for each of those 8. I'm only dealing with differences, so my degrees of freedom is 7. So I would find this value by finding the 7 degrees of freedom for 0.975. But again, I'm just going to let the calculator do all of the work for me. So I'm going to go in and do a confidence interval for 95% and click compute, and I get the 1.94 and 28.3, and that's my conclusion. And again, notice I'm saying points better on their post-test than their pre-test, and I could put all of that together in one conclusion. So here's one for you to try. So press pause, enter this data into your StatCrunch, perform the test and the interval, and then write your conclusion. So in this question, we're dealing with physical fitness and a resting heart rate, and we're hoping that this is before exercise and after exercise. Our goal here is, of course, for their pulse rate to decrease. So again, first I would check my conditions. The data are paired. That's super important. So let's talk about that for a minute. I have a lot of students who just say, oh, well, there's the same number in each group, so they must be paired. This is certainly paired because this is a pulse rate before and after exercise of the same person. That is why it's paired. It's not just that we happen to have the same number. So if you've watched the video using the battery life, I also had the same number of batteries of generic and name brand, but those were not paired because they were not the same battery. So make sure that you're only using this if the data are paired. I check the rest of the conditions and say the conditions are met. We'll use a student's t-model and a blocked pairs t-test and interval. The hypotheses, the mean of the differences is 0, meaning it's the same heart rate before and after, or pulse rate. And then for this one, I said the mean of differences was less than 0 because I was saying that rate after an exercise routine will be lower than the pulse rate before. Now, of course, that means I have to subtract it in the proper order. If I did it the other way around, I could say that the differences would be greater than 0. It just depends on which order you're going to subtract. So again, notice I've done this by hand here, and I found that the mean of differences was negative 2.8. Again, negative because I'm expecting the afters to be smaller, so I took after minus before. Again, in my calculator, I would go to Stat, t-stats and paired, because this is paired data. And if I do after and then before, and then this was a less than 0, I can compute. And notice if I do after minus before, I'm expecting that value to be negative. If you really just hate the negatives, you could change this to greater than 0. We would say that the pulse rate before would be greater. You'd end up with positive numbers. I kept this one negative just so you could see what it looked like. And again, notice I got an interval here. The test was 0.0034, which of course means we're rejecting. If I change this to a confidence interval instead, 90%, and notice I get that negative interval, again saying that that's how much it decreased by. So here, notice I didn't use the negatives. I said decreased on average from 1.33 to 4.27 beats per minute because they were negative. So either way you do it, whether you deal with positives or negatives, we have to know which one is greater than the other.